morning, doctors. In this video, we shall be discussing about variation of conductance G, ease with which the current is flowing, specific conductivity kappa, when the distance between electrode is 1 centimeter and the cross-sectional area of electrode is 1 centimeter square, then conductance is known as specific conductivity, or this is the conductance of 1 milliliter of the solution. Specific conductivity, equivalent conductivity, which is the conductance of 1 gram equivalent of that much volume of solution which contains 1 gram equivalent of the electrolyte. Next is molar conductivity, which is the conductance of that much volume of the solution which contains 1 mole of electrolyte. So we'll see the variation with dilution when we are adding water to it and the volume is increasing. So basically what happens, conductance increases with increase in dilution. Why this happens? क्योंकि conductance होता है ease with which the current is flowing, और ये आयंस की वजह से होता है. जब हमारे पास एक सोल्यूशन है उसमें आयंस हैं जैसे कि Na पॉजिटिव एंड Cl नेगेटिव, अगर हम इसमें वाटर डाल रहे हैं सो वाटर डालने की वजह से मोर नंबर ऑफ आयंस विल बी प्रोड्यूस, मोर NaCl विल गेट decomposited to form Na positive and Cl negative. So आयंस बढ़ रहे हैं, आयंस के बढ़ने की वजह से conductance will also increase. Now conductivity. Conductivity is the conductance of 1 milliliter of the solution. So now what happens when we are adding water to it? So 1 milliliter में जितने आयंस थे वो कम हो रहे हैं. पहले ये पास पास थे, लेकिन अगर हमने इसमें ज्यादा वाटर डाल दिया पूरे सोल्यूशन में सो ये दूर दूर हो गए, जिसकी वजह से conductivity is decreasing. So conductivity decreases with dilution. Next is equivalent conductivity. That much volume which contains 1 gram equivalent of the electrolyte. Now what happens if 1 gram equivalent electrolyte we are adding water to it? So इसमें आयंस सेपरेट हो जाएंगे और आयंस के सेपरेट होने की वजह से मोलर इक्विवेलेंट कंडक्टिविटी विल इंक्रीज. आयंस सेपरेट हो जाएंगे, उनके बीच में इंटरेक्शंस कम होंगी एंड दे विल बी मोर फ्री टू मूव. सो कंडक्टेंस विल इंक्रीज, सो इक्विवेलेंट कंडक्टिविटी विल इंक्रीज. नेक्स्ट इज मोलर कंडक्टिविटी. नाउ मोलर कंडक्टिविटी इज conductance of that much volume which contains 1 mole of electrolyte. Since on adding water or on dilution, ions will separate, ions जो होंगे उनके बीच की interactions कम होंगी, so as a result ions will move more frequently, so conductance will increase, molar conductivity will increase. So electrolytic conductance, equivalent conductivity and molar conductivity increases with dilution, whereas specific conductivity kappa decreases with dilution. So conductance of a solution, conductance is due to presence of ions, ease with which the current is flowing. Greater the ions, greater will be conductance. And if we are adding water to a solution, so number of ions, more ions will be produced, more the electrolyte will decompose to form the ions, and as a result conductance will increase. Specific conductance or conductivity is the conductance of 1 milliliter of the solution. As we are adding water to it, so ions present per milliliter per centimeter cube of solution becomes less and less. As a result, specific conductivity decreases. Molar conductivity is defined for 1 mole of ions, that much volume which contains 1 mole of ions. When we are adding water to it, so what is happening? Ions are moving apart. As a result, mobility is increasing and molar conductivity increases. So molar conductivity, यहाँ पे क्या हो रहा था, यहाँ पे वॉल्यूम हमने फिक्स कर दिया, यहाँ पे वॉल्यूम इज नॉट फिक्स्ड बट मोलैरिटी और मोल्स आर फिक्स्ड. सो 1 मोल में आयंस डिल्यूशन की वजह से their distance will increase, they will move apart. So as a result their mobility will increase, so molar conductivity will increase. Molar conductivity is kappa into volume or kappa into 1000 upon molarity. Now kappa is decreasing but volume is increasing and molarity is decreasing. So decrease in molarity or increase in volume is much more than the decrease in conductivity. So as a result molar conductivity increases. इसके डिक्रीज करने की वजह से डिक्रीज करना चाहिए था, लेकिन वॉल्यूम ज्यादा इंक्रीज कर रहा है और मोलैरिटी ज्यादा कम हो रही है. सो एज ए रिजल्ट जो नेट इफेक्ट होगा मोलर कंडक्टिविटी विल इंक्रीज. नेक्स्ट इज इक्विवेलेंट कंडक्टिविटी. दिस इज डिफाइंड फॉर 1 ग्राम इक्विवेलेंट ऑफ आयंस. वॉल्यूम फिक्स नहीं है, 1 ग्राम इक्विवेलेंट ऑफ आयंस है. सो वॉल्यूम अगर हम इंक्रीज करेंगे सो आयंस विल मूव अपार्ट एंड मोबिलिटी विल इंक्रीज. सो एज ए रिजल्ट equivalent conductivity will increase. Equivalent conductivity is kappa into volume. Now kappa is decreasing but volume is increases. Volume ka increase hoga, this will compensate the decrease in conductivity. So as a result equivalent conductivity increases. Or normality is decreasing. So as a result equivalent conductivity increases. Kappa decreases, we have already discussed here. Volume increases because we are adding more water. Normality decreases because concentration is decreasing. So equivalent conductivity increases. Variation of molar conductance with concentration. This is different for a strong electrolyte and different for weak electrolyte. Strong electrolyte are almost completely ionized in solution. So इनमें क्या होगा, when we are decreasing the concentration, the ions will move far apart from each other because they are already 100% or nearly 100% dissociated, but they are near to each other. When we are increasing dilution or when we are adding more water to it, these ions will separate. So interionic attractions will decrease and movement of ions will increase, due to which there will be more molar conductance due to this. So on increasing dilution, molar conductance increases but only to a smaller extent, not that much, like this. It was already greater and it increases with decrease in concentration or with increase in dilution, but that increase will be only little. In case of weak electrolyte are not completely ionized or dissociated. For example, acetic acid. It is not ionized, it is ionized less than 5%. It is less than 5%, alpha is less than 5% or equal to 5%. Now when we are adding water, so it will become more dissociated. So number of ions are increasing in this case. So as number of ions are increasing, molar conductivity will be more. The conductivity by 1 mole of electrolyte will be more, as 1 mole of electrolyte will give more ions. So as a result, conductance will increase with increase in dilution or decrease in concentration, and it will reach maximum value when the concentration approaches 0. और when dilution approaches infinite value. So strong electrolyte के लिए different है and weak electrolyte के लिए भी different है. यहाँ पर reason था कि water डालने पर ions जो है दूर दूर हो रहे हैं और उनकी mobility increase हो रही है, और यहाँ पे reason था कि water ज़्यादा add करने पर जो electrolyte है वो ज़्यादा dissociate कर रहा है, so number of ions increase कर रहे हैं, तो molar conductivity will increase in both the cases. So for strong electrolyte, there is only small increase in conductance with dilution. When we are adding water or when we are decreasing the concentration, only small increase in conductance is observed. Why? Because strong electrolyte is almost completely dissociated in solution. So number of ions are same. Only when we are increasing the dilution or decreasing the concentration, पहले से इसमें आयंस बहुत ज़्यादा है, बस जैसे ही हम इसमें पानी और ज़्यादा डाल रहे हैं, सो आयंस आर मूविंग फार अपार्ट एंड द इंट्रैक्शन बिटवीन दैम इज डिक्रीजिंग. सो एज ए रिजल्ट देयर मोबिलिटी इज इंक्रीजिंग एंड कंडक्टेंस इंक्रीजेस विद डिल्यूशन एंड इट अप्रोचेज मैक्सिमम वैल्यू एट इनफाइनाइट डिल्यूशन और व्हेन द कंसंट्रेशन इज 0. मोलर कंडक्टिविटी एट 0 concentration और मोलर कंडक्टिविटी एट इनफाइनाइट डिल्यूशन. हियर द वैल्यू इज प्लॉटेड और इस तरीके से स्मॉल इंक्रीज इन कंडक्टेंस इज ऑब्जर्व्ड. And on x-axis we have plotted concentration, root of concentration, and in y-axis we have plotted molar conductance. So dilution बढ़ाने पर हम इस तरफ जा रहे हैं, that means concentration कम हो रही है, small increase in conductance is observed. What if we are writing equation for this? We very well know line के लिए equation होती है y is equal to mx plus c. y पर दिया है lambda m and m slope is negative because ये decrease कर रहा है, so let us take it as minus a, and x पर है root of concentration plus molar conductivity at infinite dilution. So this is molar conductivity, whereas this is m infinity is molar conductivity at infinite dilution or at 0 concentration. C is concentration of electrolyte and A is a constant which depends upon what type of electrolyte we have used. Is it KCl, HCl? Nature of the solvent in which we have dissolved it, is it water or some other solvent? Next is temperature. We very well know on increasing temperature dissociation increases. So temperature, these three factors the A depends upon. And in case of weak electrolyte where degree of dissociation is equal to or less than 5%, so उसके केस में कंडक्टेंस में लार्ज इंक्रीज ऑब्जर्व किया गया है, क्योंकि जैसे हम वाटर ऐड कर रहे हैं, सो देयर विल बी मोर डिसोसिएशन ऑफ द weak electrolyte. So as a result, more of ions are forming, more of it is ionizes. So when concentration is decreased or when we are adding more water, so number of ions increase करेंगे, due to which conductance भी increase करेगी, and this conductance will will be greater increase in conductance, because यहाँ पे number of ions बढ़ रहे थे, whereas in case of strong electrolyte ions were not increasing but mobility was increasing, and here number of ions are increasing, so that is why increase in conductance is more as compared to strong electrolyte. But it does not reach a limiting value, because a weak electrolyte is never 100% ionized, or we can never have infinite dilution in this case. Some amount of acetic acid will remain in the water because it is never completely dissociated, so it will never reach limiting value, और molar conductance is zero concentration, molar conductivity at infinite dilution. ये वाली वैल्यू हम कभी ऑब्जर्व नहीं कर सकते, अगर हमने निकालनी है, so we have to study another law which is Kohl-Rasha's law. यहाँ पे हमने निकाल लिया था Debye-Heckel-Onsager equation से, but weak electrolyte के लिए we have to study Kohl-Rasha's law. So Kohl-Rasha's law was given to calculate limiting molar conductivity of weak electrolyte, because graphically तो वो निकल नहीं रहा था. So Kohl-Rasha observed कि जो ions होते हैं, ion की conductivity are independent of one another. For example, if we are considering aluminium sulfate Al2SO4 whole thrice, so यहाँ पे जो ionic conductivity होगी aluminium की, that will be independent to the ionic conductivity, limiting ionic conductivity of sulfate ions. These both are independent of one another, and the molar conductivity at infinite dilution of whole of the electrolyte aluminium sulfate, this will be equal to limiting ionic conductivity of aluminium multiplied by number of ions. 2 ions है तो 2 की molar conductivity, 3 ions है सल्फेट की तो 3 की limiting molar conductivity. इसके बराबर होगा total limiting molar conductivity of electrolyte, which is sum of limiting ionic conductivity of cation and limiting ionic conductivity of anion multiplied by number of ions present in the electrolyte. So this was Kohl-Rasha's law. For example, if we are considering this for acetic acid, अब ये तो इसके लिए निकालना easy है, लेकिन अगर हम limiting molar conductivity निकाल रहे हैं for acetic acid, so this value will be equal to limiting ionic conductivity of acetate ion plus limiting ionic conductivity of H positive ions. Now ये वाली वैल्यू हम नहीं निकाल सकते ग्राफिकली, सो इसके लिए हम क्या करते हैं, स्ट्रॉन्ग इलेक्ट्रोलाइट की टर्म्स में लिख लेते हैं इसको, प्लस माइनस करके अगर ये वाली वैल्यू आ रही है, फॉर एग्जाम्पल लिमिटिंग मोलर कंडक्टिविटी ऑफ CH3COOK, दिस इज अ स्ट्रॉन्ग इलेक्ट्रोलाइट, प्लस limiting molar conductivity of HCl, this is a strong electrolyte. Now CH3COO मिल गया, H भी मिल गया, एक्स्ट्रा क्या आ गया, H और Cl, so we have to minus limiting molar conductivity of KCl, this is not H, this is K, CH3COOK, this is strong electrolyte, this is also a strong electrolyte, but this will give the value of limiting molar conductivity of CH3COOH, which is a weak electrolyte. So by Kohl-Rasha's law, we can calculate the limiting molar conductivity of weak electrolyte by the limiting molar conductivity of strong electrolyte, and by this formula which we have used earlier. So Kohl-Rasha states that each ion makes definite contribution to total molar conductivity and it is independent of the other ion. So the limiting molar conductivity of an electrolyte is the sum of limiting ionic conductivity of cation and anion multiplied with the number of ion present in one formula unit. So here this is limiting molar conductivity of electrolyte, these both are limiting ionic conductivity of anion and cation. For example, if हम molar conductivity, limiting molar conductivity निकाले NaCl के लिए, so it will be equal to limiting ionic conductivity of sodium ion plus limiting ionic conductivity of chloride ion. Similarly, limiting molar conductivity for barium chloride is limiting ionic conductivity of barium plus limiting ionic conductivity of chloride ion multiplied by number of chloride ion present, which is 2, and number of barium ion present, which is 1. Limiting molar conductivity of aluminium sulfate is limiting ionic conductivity of aluminium multiplied by number of ions present, which is 2. Limiting ionic conductivity of sulfate multiplied by number of sulfate present, which is 3. This is for molar conductivity, लेकिन equivalent conductivity is the sum of limiting ionic conductivity of cation and anion, and it is not multiplied with the number of ions present. It is simply limiting equivalent conductivity is equal to limiting ionic conductivity of cation plus limiting ionic conductivity of anion. Relationship between molar conductivity and equivalent conductivity, we have already discussed this. This value is equal to n factor. N factor number of ionizable H positive or OH negative ions. Same is the case with limiting molar conductivity and limiting equivalent conductivity. इनका ratio भी is equal to n factor number of ionizable H positive or OH negative ions. I have already discussed in previous video the relationship between molar conductivity and equivalent conductivity. If we divide this both, we'll get n factor. Next is calculation of molar conductivity at infinite dilution. Infinite dilution, that means at zero concentration for weak electrolyte. For example, if we are considering for acetic acid, this will be limiting ionic conductivity of acetate ion plus limiting ionic conductivity of H positive ion. Now we don't know these values because weak electrolyte के लिए limiting molar conductivity निकालना from the graph is not possible. So what we do is we calculate for strong electrolytes जिनमें ये वाले ions आ रहे हैं, KCl, CH3COOK, HCl के लिए आ गया. Now what happens? Acetic acid के लिए CH3COOK plus HCl. So we have got CH3CO and H also. But what is additional? K and Cl. So we need to minus the molar conductivity of KCl electrolyte. So we'll get the value of molar conductivity of acetic acid. Next is molar conductivity of ammonium hydroxide, since it's a weak electrolyte. So limiting ionic conductivity of ammonium ion plus limiting ionic conductivity of hydroxide ion. But calculating this is not possible. So what we do is हम इसका strong electrolyte ढूंढते हैं. Molar conductivity of ammonium chloride, यहाँ से आ गया इसका. Limiting molar conductivity of सोडियम हाइड्रोक्साइड, वहां से हाइड्रोक्साइड आना चाहेगा, यहाँ पे एक्स्ट्रा क्या है? सोडियम एंड क्लोराइड. सो वी हैव टू माइनस लिमिटिंग मोलर कंडक्टिविटी ऑफ सोडियम क्लोराइड. So we'll get limiting molar conductivity of ammonium hydroxide. So Kohl-Rasha's law is also important in calculating the degree of dissociation. The extent to which the electrolyte is dissociating, that is alpha. This is equal to molar conductivity upon molar conductivity at infinite dilution. मोलर कंडक्टिविटी अभी कितना वो कितना उसकी कंडक्टिविटी है डिवाइडेड बाय इनफाइनाइट पर कितनी होगी, इनफाइनाइट डिल्यूशन पर. दिस वैल्यू गिव्स अस डिग्री ऑफ डिसोसिएशन. आइडियल कितनी होनी चाहिए और अभी कितनी है और ये कितना टूट रहा है हमें यहाँ से पता चलेगा. वेयर दिस इज मोलर कंडक्टिविटी, दिस इज मोलर लिमिटिंग मोलर कंडक्टिविटी. अब अल्फा की वैल्यू आ गई डिग्री ऑफ डिसोसिएशन. सो वी कैन इजीली कैलकुलेट डिसोसिएशन कांस्टेंट विच इज इक्वल टू सी अल्फा स्क्वायर अपॉन 1 माइनस अल्फा, वेयर सी इज कंसंट्रेशन ऑफ इलेक्ट्रोलाइट. Limiting molar conductivity are given. We have to find limiting molar conductivity of acetic acid, which is equal to limiting ionic conductivity of acetate ion and H positive ion. So हमने यहाँ पे देखना है कि acetate ion कहाँ से निकल रहा है. Limiting molar conductivity of CH3COOK से, यहाँ से acetate ion आ गया, लेकिन हमें K नहीं चाहिए. पहले हमें H positive भी देख लेते हैं, ये कहाँ से आएगा. Limiting molar conductivity of H2SO4 से, लेकिन हमें सिर्फ H चाहिए था, यहाँ पे H2 आ रहे हैं. So we have to multiply this by half, या हाफ चाहिए हमें. देन अब यहाँ पे एक्स्ट्रा क्या आ गया, K और SO4 आ गया. तो KSO4 को माइनस करना है. यहाँ पे गिवन है लैम्डा m, दिस इज K2SO4. इसका हाफ चाहिए. सो वी हैव टू मल्टीप्लाई दिस बाय हाफ. K हाफ चाहिए इसको माइनस करने के लिए, ये भी हाफ चाहिए इसको माइनस करने के लिए. नाउ CH3COO के लिए क्या दिया है, दिस वैल्यू इज दैट. वेरएज H2SO4 के लिए कितना दिया है, दिस वैल्यू इज हाफ ऑफ x. माइनस K2SO4 के लिए कितना दिया है, दिस वैल्यू इज हाफ ऑफ y. सो दैट मीन्स अगर हमने इसके लिए निकालना है, वी हैव टू z, इनको प्लस करना पड़ेगा. यहाँ पे क्या कॉमन है, 2 कॉमन है. यहाँ पे क्या है, x माइनस वाई अपॉन 2 प्लस z, विच इज गिवन इन ऑप्शन डी. 25 डिग्री सेल्सियस, मोलर कंडक्टेंस ऑफ 0.1 मोलर एक्वा सोल्यूशन ऑफ अमोनियम हाइड्रोक्साइड. 0.1 मोलर के लिए मोलर कंडक्टेंस गिवन है हाउ मच, 9.54 ओम इनवर्स सेंटीमीटर स्क्वायर एंड मोल इनवर्स. एंड एट इनफाइनाइट डिल्यूशन द मोलर कंडक्टेंस इज गिवन एज 238 ओम इनवर्स सेंटीमीटर स्क्वायर एंड मोल इनवर्स. यूनिट इनकी सेम होनी चाहिए. एंड वी वेरी वेल नो डिग्री ऑफ डिसोसिएशन इज इक्वल टू मोलर कंडक्टेंस अपॉन लिमिटिंग मोलर कंडक्टेंस. दोनों की वैल्यू को डिवाइड कर लेंगे. सो ये वैल्यू क्या देती है हमें, डिग्री ऑफ आयनाइजेशन, वो कितना डिसोसिएट कर रहा है आयन. सो दिस वैल्यू इज 0.04008. नाउ यहाँ पे पर्सन में दिया है, सो पर्सन में कन्वर्ट करने के लिए वी हैव टू मल्टीप्लाई दिस बाय 100. 2 पॉइंट आगे शिफ्ट होंगे, आंसर विल बी 4.008%, विच इज गिवन इन ऑप्शन फर्स्ट. Limiting molar conductivity of NH4OH is given as, ये वीक इलेक्ट्रोलाइट है, इसको स्ट्रॉन्ग इलेक्ट्रोलाइट की टर्म्स में लिखेंगे. लिमिटिंग मोलर कंडक्टिविटी ऑफ NH4 वाला कौन सा स्ट्रॉन्ग इलेक्ट्रोलाइट होता है, NH4Cl. OH वाला कौन सा होता है, यहाँ पे गिवन है NaOH, दिस इज NaOH. नाउ यहाँ पे एक्स्ट्रा क्या आ गया, हमें सिर्फ NH4 और OH चाहिए था, NaCl एक्स्ट्रा आ गया. सो वी हैव टू माइनस लिमिटिंग मोलर कंडक्टिविटी ऑफ NaCl. देखते हैं कौन से ऑप्शन में दिया है, NH4Cl, NaOH, NaCl. Option D will be the right answer to this. Molar conductivity at infinite dilution of NaCl, HCl and sodium acetate are given. We have to find for acetic acid. Acetic acid is a weak electrolyte. We have to write this in terms of strong electrolytes. जैसे सोडियम एसिटेट लिख लिया, HCl लिख लिया, यहाँ से एसिटेट आयन मिल गया, H पॉजिटिव आयन मिल गया. ना एक्स्ट्रा क्या है, NaCl. सो इसको माइनस करना पड़ेगा. NaCl की लिमिटिंग मोलर कंडक्टिविटी सोडियम एसिटेट के लिए दिया था 91, HCl के लिए given was 425.9 and NaCl के लिए it was 126.4. So if we solve this, answer is 390.5 Siemens centimeter square per mole, which is given in option D. So increase in equivalent conductance of strong electrolyte is mainly due to strong electrolyte होते हैं which are completely dissociated in water to form H positive and Cl negative. Now if we are adding water to it, already they are dissociated, but when we are adding water, interionic attraction decreases, so they move far apart and ionic mobility is increasing, due to which conductance increases but not that much. So यहाँ पे थोड़ा सा increase होगा because of increase in mobility of ions. Whereas in case of weak electrolyte, they dissociate less than 5%. For example, acetic acid dissociate to give acetate ion and H positive ion. So here what happens? Ions increases. As we are adding more water, more number of ions are produced. So here number of ions increases. So as a result, the increase in equivalent conductance is more. So in case of strong electrolyte, it is due to increase in ionic mobility, which is given in option first. The following correctly represent equivalent conductance and infinite dilution of aluminium sulfate. So limiting equivalent conductance of aluminium sulfate is equal to limiting equivalent conductance of aluminium plus limiting equivalent conductance of sulfate. Now if we were asked limiting molar conductance, in that case limiting molar conductance of aluminium ion multiplied by number of ions which is present, that is 2. Limiting molar conductance of sulfate ion multiplied by number of ions which is present, which is 3. लेकिन equivalent conductance में number of ions multiply नहीं होंगे, but molar conductance में we have to multiply the number of respective ions. So यहाँ पे equivalent conductance पूछा है, so option will be option B. Equivalent conductance of M/30 solution is 8. Equivalent conductance is given, and at infinite dilution it is 400. We very well know equivalent conductance upon limiting equivalent conductance gives us the value of degree of dissociation. So पहले हम degree of dissociation निकालेंगे तभी dissociation constant आएगा. This value is how much? 8, and at infinite dilution it is 400. इसको अगर हम solve कर लें, so answer will be 0.02. उसको यहाँ पे पुट कर देते हैं. K is equal to C alpha square upon 1 minus alpha. Since alpha is very less than 1, so हम इस वैल्यू को निगलेक्ट कर देते हैं. Let it be 1, so it will be C alpha square. So Ka की वैल्यू आ जाएगी C की वैल्यू कितनी थी? M/32, that means 1/32 molar multiplied by alpha की वैल्यू दी है 0.02 multiplied by 0.02. So if we solve this value is 2 into 2 upon 32 multiplied by यहाँ पे कितने 0 हमने पीछे लिए 10 raised पर -4, and this value is how much? 2 2s are 4, 4 upon 32 into 10 raised to the power -4. अगर हम इसको सॉल्व करें, we'll be getting 0.125 multiplied by 10 raised पर -4, लेकिन आंसर 10 raised पर -5 में दिया है. Let us divide this by 10 and also multiply this by 10. हमें आगे बढ़ाना है तो we have to multiply this. आंसर आ जाएगा 1.25 into ये बेसिस सेम है, डिवाइड में पावर सब्ट्रैक्ट हो जाएंगी. So answer will be 1.25 into 10 raised to the power -5, which is given in option D. Rasha's law states that Rasha's law is for weak electrolyte, जहाँ पर we cannot calculate the limiting molar conductivity, that means molar conductivity at infinite dilution. So in that case we use Rasha's law, that means infinite dilution. Each ion makes definite contribution. Each ion makes definite contribution, we have already discussed, to total ionic conductivity, irrespective of nature of other ion. It does not depend on the nature of other ion. That means at infinite dilution, each ion makes definite contribution to conductance of an electrolyte, whatever be the nature of other ion. Not to equivalent conductance, but to conductance. Now the conductance can be equivalent or molar. So option will be option first. Equivalent conductance of barium and chloride ions are given. It is 127 and it is 76. Equivalent conductance of barium chloride at infinite dilution. Limiting equivalent conductance. So limiting equivalent conductance is equal to limiting equivalent conductance of individual ions. यहाँ पे कोई multiply नहीं होता है, multiply molar conductance के केस में होता है. If we were asked molar conductance, तो यहाँ पे chlorine ions 2 के साथ multiply हो जाता, लेकिन equivalent में ऐसा नहीं होता. So barium के लिए it is given 127 and chlorine के लिए it is given 76. So if we add this, we'll be getting answer 203, which is given in option C.